7.1, the section you guys were just aching to get to because you were tired of working with fractions. We're going to start talking about some decimals. All right, sound good? All right. First of all, decimal comes from the Latin word meaning 10, D-E-C, des, right? So that part of it comes from the word 10. And what I want to talk about first is some of the language involved with our decimal system, which is the system of math that we use for our number system. So to start with, I'm going to draw a few things on our screen. I'm going to draw just for now 5 lines to the right here. And understand that they keep going and they keep have names and so forth. But we're just going to talk through some of the names of these. The first one here, this is my decimal point. And when we see the decimal point and read a decimal value properly, we say the word and. All right? This location, what do you call this location? One to the right of the one to the left of the decimal point. The ones place, or sometimes you'll hear it called the units place. Those are kind of used interchangeably. What's this placeholder called? That is the tens. Now, these two places right here sort of form the center of our diagram, and then everything is mirror images on the other side, on each side from each other. So if the left-hand side outside of my purple box here was the tens, then this one is the tenths. So we add THSs on the ends of things. The next place is the hundredths. After that, I have the thousandths. After the thousandths is the good 10,000. Sometimes that trips people up. 10,000ths. The last one that I've got drawn up here would be the 100,000ths. Just curious, what would come next? Do you know what comes after 100,000ths? No. Millionths. Somebody said it. It's millionths, right? And if you aren't sure when you're moving to the right-hand side what comes, if you think about the left-hand side, what would come after the 100,000s place? It would be the millions place. And then the 10 millions and the 100 millions and then the billions, and then likewise on the other side it would be billionths, right? All right, so what we're going to do with this is we're going to actually learn how to say words properly that we've been saying incorrectly for quite some time. Because I do it too. How do you say that word like in real life, like in normal, everyday talking? What are you going to say when you see that number? 32.4236. And sometimes people say dot now, right? They'll use the word dot in the middle there instead. So, I mean, that's how we think. And often, if we're talking about dollars and cents, of course, you know, only 2 decimal places, we say that a little bit differently too, right? So we're going to actually write this in words properly, okay? This is what you're supposed to do when you write a check. I don't know if any of you have ever written a check before. It's sort of gone by the wayside for a lot of people, just swipe cards. But this is actually how you're supposed to write on a check as well. All right, so this part right here gets written all together before your decimal point. So what would we write for this number? This one we usually say, right? 32, that's right. So and there is a hyphen between the 30 and the 2. 32. And then after that, we have a decimal point. And when we see the decimal point, we say and. Now, what comes next is a little bit tricky just because this one's long and it feels a little awkward. We need to identify what place value that 6 is in. Which place is that in? That is in the 10,000s. So keep that in mind as we work. What we're going to write is we're going to write this number as though it doesn't have any, we're just going to write it as the number 4236. So what would that number be, 4236? What would I write? 4,000 Notice there is not a hyphen between the 4 and the 1,000. 4,000. What'd you say, 200? 200. What? 36. There is a hyphen between the 30 and the 6. And then we actually have to say what place value it's in, and that's when we say 10 thousandths. There aren't in what I've written down. I don't think there's supposed to be. If you put some commas in there to separate some things, I'm not too concerned about the comma situation. I'm not going to complain too much about the hyphens either. And the reason I'm not is because I'm more concerned that you can say it right than you can write it exactly properly. And if you've got the right words in there, we're pretty much we're 90% good, and that's good. So. One thing I want you to be aware of, this actually happened when I was visiting my daughter's class trying to help out. So this is a whole number, I know, but I want you to say that number. 432. The classroom that I was observing, even the teacher was doing this. The tendency for people is to actually put the word and in places that it's not necessary. So they would say, this is what she did. She said 432. And so you have to remember when you're working with, I have a distinct memory of second grade. I remember this, I know it was in second grade, and the teacher being very angry because I kept putting and in words that I wasn't supposed to put and in, and telling me that means something later, but not telling me what, which meant nothing at the time, right? Like that's just almost like crazy confusing. But it is incorrect to say 432. The and actually means the decimal point. So keep that in mind as you're writing these and saying these. All right, we're going to go the other direction now. We've got a word written out, and we're going to write the numbers, the numerals that correspond to it. So somebody tell me what numeral I need to write down. 536, okay, 536, and then what? A decimal point, thank you. And then what comes next?
076.
Very good. Why is it 076 and not just 76? I mean, it doesn't say 0 anywhere in here. Right, it says thousandths, which means the placeholder where I need to end is the thousandths place. So that 76 has to stop at the thousandths place. It's 3 decimals in. Good. Very good, guys. All right, we're going to talk about base 10 expanded form, and I am going to deviate a little bit from what your book does with good reason, so I'll explain my reasoning as we go. So first of all, let me draw those same 7, I put bars before, and we'll talk about what base 10 expanded form means. So I drew these bars before, and we talked about in words what they mean. And base 10 is their number system that we use, and I know you guys, many of you have heard me say this before, but why do we use base 10? Because we have 10 fingers. I mean, this is the reality of where that came from, okay? So the base 10 comes from there. We have 10 numerals. Our numerals are actually from 0 to 9. 10 is not a numeral, it's a 2-digit number. So this placeholder, we'll start with, like we did right here before, is the ones place. And you can write that as just 1 for right now, and we can write this as 10 for right now, okay? But what I want to do is actually want to focus on the right-hand side, the part where our decimals come into play. So this first decimal place, we said it was 1/10. Well, the tenths place, 1/10, is the number 1 over 10. That's what it means. Okay? This is the hundredths place. That means 1 over 100. If you think about your coins, that's exactly what we mean when we talk about a penny. It's 3 pennies out of 100. It's 3 100ths of a dollar. And we can keep working to the right with that kind of a mindset. Basically, this is the thousandths place, so we write 1,000 on bottom. This is the 10,000ths place, so we write 10,000 on bottom. And then this one's the 100,000ths place, so we write 100,000 on bottom. Now, here's where I want you to see, well, actually I write it down at the bottom, so I'll mention it in a minute. All right, so one of the kinds of questions that we're going to look at is this question of writing an expanded form. So this number right here that we have is we have 103 and 300ths, right? That's the words that we would say that in properly. So what I would like you to do is to break them apart by place value. So this is 1 times 100 plus 0 times 10 plus 3 times 1. So we did that in Math 1, for those of you who've taken it. We've seen that happen before. And then on the right-hand side, we're going to write 0 times 1/10 and 3 times 1/100th. And we are going to put zeros in for the missing ones, and we're going to include those. And this is what I want to see when we talk about expanded form. Intuitively, this is what those place values mean. Now here's what you're going to see if you look at the back of the book for this problem. Okay, so this is what the back of the book is going to say. It's going to say 1 times 10 squared plus 0 times 10 to the 1 plus 3 times 10 to the 0 plus 0 times 10 to the negative 1 plus 3 times 10 to the negative 2. And it's absolutely correct. There's absolutely nothing wrong with writing it that way. It just loses the intuitiveness of what the whole point was in doing base 10. I mean, when I look at 10 to the negative 1, I'm not thinking about decimals at all anymore. And I'm certainly not thinking about the relationship of how I think about the word or the fraction 1/10 and the decimal place value system. So I would like for you to not use this notation. You guys understand it, I think, enough because of what we've done with exponents so far to look at the back of the book and make sure you did it right. But this is the notation that makes what we're actually doing more helpful instead of less helpful. So we're going to leave it written that way. Does that make sense to everyone? Okay. We're going to talk about drawing a square grid. A decimal square grid is a 10 by 10 grid that contains 100 small squares. So we're going to draw a decimal square grid for the number 0.23 or 23 hundredths, right? So the way this works is you're going to draw yourself a large square and you're going to split it into 10 rows and 10 columns, all right? And I'm going to do it over here. So my picture will hopefully look reasonably good. All right, so there is a 10 by 10 grid, and hopefully you have one as well. So there's 100 little boxes inside. So if we're doing the value 23 hundredths, we need to shade in 23 of these boxes. So the easiest way to do that is to shade in 1 complete row, 2 complete rows, that's 20 boxes, and then 3 more. Alright, so there is my decimal square grid. That's all it is. That's all a decimal square grid is. I actually think, decimal square grids are fine. There's nothing wrong with them. I actually think when we're looking at a 10 by 10 or something with 2 decimal places, it's a lot more intuitive for children to think about money. And so money is a really good visual to talk about this as well. You could actually, you can actually use real coins and it doesn't even cost you very much. Like if the kid steals the pennies, what are you out? Some pennies. Really, it's not a big deal. So I've actually used money in a classroom before when we've done different stuff like this because kids understand money. At least they understand somewhat of it, especially at the point when they're learning about some of the decimal stuff, which is about 6th grade. They've got a pretty good conception of that, so that's a helpful visual for them. All right, so that's how we would draw a decimal square grid. All right, so the next things we're going to look at is we're going to look at deciding whether or not a fraction can be written as a terminating decimal. So the theorem 7.1 says that you can write a fraction as a terminating, that means ending, stopping, decimal point if it has one feature. Okay, first you have to reduce the fraction. So you're always going to reduce the fraction before you start. So if you start with a fraction 300 over 400, the first thing you better do is write it as 3 over 4, or the process is generally not going to work. Okay? So you must reduce the fraction. So after you reduce the fraction, what you do is you look at the denominator. And if the denominator factors into only 2's and 5's, that doesn't mean it has to have 2's and 5's, but it means it can't have anything else. Nothing besides 2's or 5's. Then it's a terminating decimal. Okay? So the ones that I have right here actually are already in reduced form. I've got 3/8 and I've got 5/12. So 3/8 is in reduced form. So what we do is we take the denominator, 8, and we factor it. Now, I've shown how to factor to some of you guys before, but just to remind some of you others, we can use factor trees. That's great. I'll use a factor tree on this one, and then I'll do the other one differently. If I use a factor tree, what two numbers would divide, or give me two numbers that divide 8? 4 and 2. And then we'd take the 4 and we'd write it as 2 and 2. So the 8 is 2 times 2 times 2, right? That factorization can have 2's, 5's, or 2's and 5's. And this one does, in fact, only have 2's. So this one terminates. Because its factorization doesn't have anything but 2's and or 5's. Okay? And then it says, if it terminates, write it as a terminating decimal. So, what does that mean? Well, it means we're really going to divide the thing. Okay, so we're going to put the 8 on the outside, and we're going to put the 3 underneath, and we're going to talk about division with fractions. Now, we're going to talk a little bit more about some division otherwise with fractions later, but 8 does not go into 3, so we have to have the decimal point, and then we rather ignore the decimal point as we're working, right? We say, how many times does 8 go into 30? 3. And we write the 3 above the 0 of the 30. We can also bring the decimal point straight up above where it was. 3 times 8 is 24. And then we subtract. What do we get? 6. We need to add a 0. So now we're going to do 8 goes into 60 7 times. 7 times 8 is 56. And we subtract and we get 4. And we bring down one more 0. 8 goes into 40 5 times. 5 times 8 is 40. And we're done when we have a remainder of 0. And so the terminating decimal here is either, you can write it as 0.375 like that, 375 thousandths, or you can write it as, there's my number, the 0 with the 0 in front. It doesn't make any difference. Either of those would be fine. Okay, so far so good? All right, let's look at the other one then. The next one is 5/12. 5 and 12 don't have anything in common, so it's in reduced form. Which means the next thing I do is I divide the 12 and figure out what divisors it has. So what I'm going to do is I'm actually going to do this. I'm just going to do it in a little bit different way that you guys, than a factor tree. What is the smallest number that divides 12? 2. 2 goes into 12 6 times. And I'm not going to get any remainders when I'm doing this because that's the whole point in the numbers I'm choosing. What divides 6? 2. And 2 goes into 6 3 times. So this is another expression of a factor tree. Put them all there on the side. I don't care which one you use, but be aware that there are other options. So the 12 is 2 times 2 times 3. Does this represent a terminating decimal? No. Why? Because there's that 3 in there. That 3 means that it's not going to terminate. Now, it is a different kind of decimal. It's called a repeating decimal, this particular one. So it's not that it isn't a decimal, it's that it isn't a terminating decimal. That's the difference here, okay? So this one is not terminating. I was right the first time. There we go, terminating. All right, the next thing we're going to look at is comparing or ordering decimals. So this is putting them in order from least to greatest or greatest to least, whatever the directions say. This one says least to greatest. The idea is to line up the numbers by place value. In particular, line up the decimal points usually. And then find the first place where they, reading from left to right, find the first place where they differ are different, and use that to compare your values. So what I need to do with these numbers, which are running together very much, don't they? I mean, like, what a mess, is I need to line them up vertically. Okay, they're so much easier to look at when they're on top of each other instead of side by side. So 13 and then a decimal point, I've got 4919. 13, the decimal point, and I've got 492. 13, 49183. And 13, 49199. Did I get them all? I think so. Now, one thing that helps some people, and especially when they're first seeing this for the first time, which none of you guys, of course, are, but one thing that sometimes is very helpful is to fill in zeros so that things have the same length. You don't have to do that, but for some people, that really makes it feel like you're comparing things with the same, number of digits, in other words. And it doesn't change the value to put a 0 on the end, of course. So for some people, that helps. So when you're working with kids, you might try that if they're having trouble with some of the other things. And I'm going to do an example of something, I guess it's in the next section, where there's a problem where a student is definitely misconstruing that fact. All right, so what we're going to do is we're going to go from left to right, comparing the numbers. So the first column is 1s, the second one's 3s, the third one's 4s, and the fourth one's 9s. All that matches. So the first place where they don't match is the thousands place, correct? So tell me what you can tell by looking at the thousands place. This one right here has a 2 in it, and it is the largest. Right? It's the biggest. After that, I don't look at that number anymore. I already know when I write these from smallest to largest, that's going to be the biggest one. I don't need to compare that number anymore to anything else. So that's sort of just off my radar now. So in terms of my numbers up here at the top, this number is number 4 in my list, and I can ignore it down here now. I've already dealt with it. So now I've got all 1s in this column, and I can compare the next column where I've got a 9, an 8, and a 9. What do I know now? The 8 is what? The smallest or the least. This is my smallest value. And that's the third one up here in the list. So this one's my smallest value. So it's actually the number I'm going to list first. This is my first value when I list things. And now again, I can rather ignore this value because I've already made a decision about it. The other two both have a 9 in that place. So if I ignore the 9 in that place on both of them and go to the next digit, I'm comparing a 0 and a 9. So what does that tell me? 0 is smaller, so this is the what? This is the second smallest. And we could write on the last one third smallest or second largest, however you want to think about it, second largest, all right. So the first one where we said the second smallest, that one's number 2. And then the second largest would be number 3. Now we have to actually do what the problem said, which is to write them in order from least to greatest. So you can either write them with like commas in between, that would be fine, or you can write them with less than signs in between, and that would be fine as well. So the first one that I'm supposed to write is the third number that's listed there, which was the 13.49183, correct? Is that okay? I'm going to use less than signs just because the commas start to look a little bit more like periods instead on my screen. The second largest, or sorry, the second smallest was the first number listed, 13, and then 0.4919. And then the third largest, which is the last number listed, 13.49199. And then the largest value that we had found was 13.492. Yes, Shelby.
On the homework, could we just like do it down the paper?
You could. We could write your answer from top to bottom down a paper. That'd be fine. And you could use commas too. They started to sort of blend in too much on my screen up here, so I didn't want to use them. And if they blend in on your paper, don't use them either. Just make it a differentiation for me. Yeah. All right, one more thing in this section. You've seen this word before. I know you have. What is the meaning of the word tithe? We use it in terms of giving. Has to do with, what was that? A tenth. That is exactly correct. So this means 1/10. So in an evangelical Christian sense, we use it in church to talk about a giving of 1/10. But tithe actually just means 1/10. It also doesn't mean like any amount that you chose to give out of what you sort of earned, right? It actually means a specific amount. It's 1/10. It's got a specific meaning. So this is 1/10 of something, whatever it is. We use it for money. The question is then, how is this related to decimals? So how is that idea related to decimals?
It's a percentage.
It is a percentage, but percentage and decimals aren't quite the same thing. They're related. How?
Like whatever you figure out, like what percentage of something, you bring the decimal over 2 places to the left.
Okay, so what would this look like in decimal form then?
1.
Okay, so this is this decimal, or this fraction, or you wanted to tell me this right here, right? 10%, yeah. All of those are equivalent. And we haven't got to percentages. We will later in chapter 7, though. That is coming very soon. But the first two are kind of what we've dealt with thus far. 1/10 and 1/10. So in practice, the way this works, we can take our income, and let's say that you made $50 babysitting, okay? And then tithe on that would be 1/10. So we haven't talked exactly about how to move decimal places for values of percentages and so forth. But 1/10 of this would be to move the decimal point 1 to the left. So you'd get $5. You could also talk about this in terms of proportions like we've done before. If you were talking about a certain amount and you wanted to know what 1/10 of it is, you can have x over 50 is 1/10. When you cross multiply, you'll find that x is 5. So that's from a fractional point of view. In essence, it moves the decimal 1 to the left when we do, in fact, find a tenth of something. So we use decimals a lot when we actually are doing conversions of things. They're very nice to convert between when you're talking about something like a tenth or 100th. Any questions? All right, that's it for this section.